Healthy in this video will show you one example how to use the matrix multiplication to solve a real-life problem. Assume you have a factory which makes two types of smartphones, Tempton and Orange. In matrix A, it shows the cost in thousands of dollars breakdown for each phone. For example, for Tempton, the raw materials cost $1.2 thousand. For Orange, the raw materials cost $1.6 thousand. Then for Tempton, the labor is $0.3 thousand. For Orange, the labor is $0.4 thousand, so on and so forth. For matrix B, it shows the production figure for each quarter, again in thousands. For example, for quarter 1, for Tempton, the production is 3 in thousands. Then quarter 2, that's 8 in thousands. For Orange, similarly, for quarter 1, that's 6 in thousands, and quarter 2, that's 2 in thousands. The question is to find a matrix that shows the breakdown cost for each quarter. What the question asks is the total breakdown for each quarter, regardless the type or the brand of phones you make. Before solving the question, let's look at some basic properties of matrix. Let's look at matrix A first. For matrix A, there are 3 rows and there are 2 columns. So it's a 3 by 2 matrix. For matrix B, there are 2 rows and 4 columns. So it's a 2 by 4 matrix. If we do A times B, we'll have a 3 by 2 matrix multiplying the 2 by 4 matrix. The AND matrix will be 3 by 4. Now, let's look at the physical meaning for the rows and the columns. For matrix A, there are 3 rows, and the meaning for that is the cost breakdown. For the 2 columns, these are the brands. For matrix B, the 2 rows are brands. The 4 columns are 4 quarters. If we do A times B, similar to what we saw just now, like the 2 is getting crossed out. When we do A times B, the brand will cross out, and the final matrix, A times B, the 3 rows will be cost breakdown, and the 4 columns will be 4 quarters. Looking back at the question, it asks you to find the matrix C that shows the breakdown cost for each quarter. And the matrix A times matrix B, it shows you the breakdown for each quarter. So matrix A times matrix B is matrix C, the one you are looking for. We can do a simple calculation now. Matrix A, let's just write that out, multiplied by matrix B. In matrix multiplication, we know that the first entry of the product matrix is the entry 1, 1 multiplied by the entry 1, 1 plus the entry 1, 2 multiplied by the entry 2, 1. Let's write that out. So this is the first entry. How about the entry at the position 1, 2? Then we'll use 1, 1 multiplied by 1, 2 plus 1, 2 multiplied by 2, 2. Again, let's write that out. How about the entry on the second row? Let's look at the entry 2, 1 in the final matrix. To get the first entry of the second row, we'll use entry 2, 1 multiplied by 1, 1. Then 2, 2 multiplied by 2, 1. So in the second row, the entry would be 0.3 times 3 plus 0.4 times 6. So we carry on this calculation. If your calculation is correct, you will see a matrix C something like this, and you can tell it is a 3 by 4 matrix. Then what is the meaning? We know that the 3 rows, that's the cost breakdown. And the 4 columns are the 4 quarters. From the matrix, you can easily read out the cost per quarter for making the phones in your factory. I want to say a couple things about the matrix multiplication in engineering applications. The first application is something we call linear transformation. You will see that in image processing a lot. The second thing is to reduce the amount of information. In this example here, you can see by doing the matrix multiplication, we drop out the information of the brands of smartphones you make in your factory. In the next video, we'll move to a new topic called Gauss elimination. Gauss elimination is a process you can quickly solve a combination of linear equations.